So one question before we get started, Joshua, do I have your call sign?
I don't have a call sign yet.
Okay.
I have to take the test. I've just had a lot of family stuff the last couple of weeks, so I haven't registered yet. But
oh, no problem.
I'm in the first.
Do you mind shooting me over your email at your convenience? So you're on the distribution?
Yeah, I'm on the groups.io.
Oh,
yeah.
you are? Okay, perfect. No problem.
Yeah.
All right. So this is really meant to be a bi-weekly technical track discussion of radio direction finders. There's been some work done by Brian and Doug, I believe, on the Cabarrus SDR. John, I think you've done some work on the system out of New York, and I can give you an update of what I'm doing on the DIY low end stuff. So, Brian, Doug, you guys want to start first?
Want to flip a coin?
Yeah, Doug, if you want to give a background, and then I'll just do some fill on it.
Sure. So our approach was pick something that we could cobble together pretty quickly, go out and look for some parts that we could basically do integration on. And Kerberos SDR looked like it was affordable enough and maybe had enough completion in the project that it would give us a rapid start. So I purchased the Kerberos SDR device. It's essentially 4 RTL SDR modules inside of a case that also has a USB hub. It can be connected to a variety of different compute machines, but the output from it is essentially IQ streams from each of these RTL SDRs. They're 8-bit I and 8-bit Q. We don't really know what that means yet in terms of whether they're going to be super beneficial to us. We don't know how they're going to perform basically, but we don't have a requirement spec. So it's pretty easy to have success, whatever it does, right? And we're going to learn some things, and we have been learning. So we have this Kerberos SDR device. It also has a noise generator on it that allows synchronization to happen in the IQ realm. And I downloaded an image for the Raspberry Pi 4, put that on there, had some false starts, but eventually got that going. There were some additional false starts because of hardware issues in the devices that we purchased, mostly the Kerberos SDR. Getting enough power in to run the 4 RTL SDRs plus the noise generator. All that aside, we eventually, last night, I got it to sync. I had it in my basement, basically surrounded by metal shelves and tables and things like that. But I took a Baofeng radio and moved around inside and used the direction of incidence on it and pushed the button. And it flipped around a little bit because I think I was getting reflections off of metal shelving. But I would say we got a hello world out of it. And so that's kind of where we're at this point. Brian was over this afternoon. We were going to do some further testing with basically a Fox on the outside, have a stationary version of this outside, and then he could move the Fox around and we would track its location, at least a vector toward its direction, not location. We encountered a few more issues hardware related issues. We got those fixed. And so Friday, we're planning on going to the next step and actually see if we can do some testing. We do need a resource at this point. And in the next, after we get some of this preliminary work done, we're going to need someone who's familiar with integrating basically a tablet or a phone through to the RPi so that we can run an application that is also available for it and test that. And that basically allows the readings from the device to be put into a map, overlaid on a map, and it'll also generate a heat map. So we can tell what the intensity of the signal is, and basically it plots a series of vectors as you drive it around so that you can locate the fox. That's where we're at. Brian, you want to add to that?
I think some of the things that I really found quite interesting was this package already includes a opportunity to merge multiple devices together to do multi-point cross-sectional identification. And that was very interesting. It's available as a very inexpensive subscription, but Doug and I thought, great, if they offer it as a subscription, we can probably do the same thing on our own server, just kind of look at this. But we're kind of approaching it as a modular solution. Doug and I had a discussion about, very early on, Jeff N5JF had just mentioned that, he was not in favor of this package just because of the 8-bit resolution or the 8-bit handling. And in talking with Doug, it seemed like possibly some of that was maybe we're not really sure what 8-bit handling really means, because like Doug said, a lot of the manipulation may be happening on board the chipset, and a lot of the interpolation and everything is happening with the data within there. So what does 8-bit really mean if you're not exporting at that point? And then also if multiple people are contributing, 8-bit from you, 8-bit from me, 8-bit from somebody else, all working together to identify a target. We're not really sure if that is a handicap or not.
Yeah.
For sure.
Yeah.
It's kind of one of those things of, if I had to land a missile in a swimming pool, probably wouldn't trust this at the get-go, but I don't really know what it'll do. And I haven't really seen yet what the DSP is at a lower level. I mean, there's a ton of Python code that basically uses a bunch of MATLib. And it's been a while since I've looked at that, but I think there's some magic that's going on to get rid of the fog in the uncertainty. We'll find out after we do a few more, fudge tests.
So do you think you can do location without any of the custom programming between the tablet and the Pi?
Yes, you can actually. You can. There's what's the best way to put it? There's an integrated direction of transmission.
Okay.
That's already built into the RPi. You just bring it up on a web page. And so there's a web page interface to this, basically a browser interface. You can also get at it from the standard image using VNC. So I do a lot of the VNC stuff. And of course, the other nice part is that you can also SSH into it and get all kinds of diagnostics and system performance monitors.
So even before the integration with the map overlay, we can test out whether it would find a fox, right?
Yes. Whether it can even hear a fox.
Yeah, maybe that's the first step, is can it find a fox?
And
Yeah, I like-
we were hoping to know that today,
Yeah.
but we'll find out on Friday.
Okay.
And we were able to identify like the repeater transmission. We were able to key it up via different RF sources in the vicinity and get approximate readings. But you know, any distance measurement and that sort of thing, we were not at that point yet.
Yeah.
And,
No,
and
that's cool.
sorry, just from a budgetary perspective, I got about $500 in cash outlay on it, and I think that between Brian and I, we probably got 15 hours invested in it. So it's not a real big investment.
Okay.
To the 8-bit thing, that's also a dynamic range
Yes.
thing, as well as just general quality. Purists will thumb their nose at an 8-bit system, but if you're trying to find something, quality is, I mean, either you find it or you don't. And we don't care about the signal quality quite as much, I don't think.
Yeah. It depends on the size.
I'm kind of 100% with the. I'm not really sure what the spec is, so I can't. I mean, if it. I'm not even really sure what my intended use is at this point. It's learn, figure out what's good or bad, and then go from there.
All right. Cool.
Yeah.
So the other one was a commercial system John was proposing out of New York. Did you find any more stuff on that, John?
Yeah, it's okay. That system, the DF 2020 F or T as it's called now, has its roots, goes back over 20 years. So it's been around quite a while under different names, and it's being sold by this one company under I have it written down here someplace, or I'll pull his. I don't know where I've got them at. The prices vary from $399 to $599. $599 is the MFJ version of it. It's the same direction finder. Its output is RS-232 9-pin and uses what they call the Agrello bearing format. Agrello is a guy that came up with the DF Junior. He was one of the first guys to come up with these little Doppler direction finders. And he came up with the idea of this output, and that's where it came from. And it is basically a bearing and a signal strength, and that's all it is. Just one little short word. And depending upon the system that you have, it will transmit up to 15 times a second. So it could be a continual output. And that would go into it's a Windows computer. There is a program called NAVI 2020. And there's other names for it, whoever, originally had, and they bought copyrights for it. And it's just a little box that goes in the bottom of the screen, and it gives you the bearing information, and you can manually put the bearing information in, and that is designed to overlay on Google Earth. I haven't gotten that far, and I don't have this new Doppler system. I realized after I started looking at all this stuff, I really can't test it, as my car is a Hyundai Santa Fe, and it's got a glass roof. Magnets don't work on glass. And my truck's a Ford, and it's aluminum. Still doesn't work. Now, I do have...
It's always the epoxy.
I don't think
I also
so,
have
Tim.
a bunch of cookie pans.
Yeah. I do have a system. Well, most of you guys have seen my truck. The big red one, the porcupine as it's called. I do have the antenna array that I have for my Doppler system fits, is bolted in, or actually pinned in, and I can flip it over upside down so the antenna array is not sticking up in the air. I would have to take and redo that with a full metal frame on it, so that I could do a mag mount. This oh boy, what do I want to call the system? The new current one, the DF 2020T, There are some issues with the antenna elements, how they mount into the box. It wasn't very well. Actually, it was kind of floating and isolated, so the ground was not connected. It didn't work very well on the, I know I'm rambling, but on the homing in website, K00F, I think is the big ham for DFing. He tested the system and he tells you how to fix it and upgrade it.
Mhm.
I do plan on getting one and trying it. I do want to get mine working first. It's been in a hiatus for a while. As I pull it out, I realized I didn't have all the parts that I needed, namely cables, 9-pin serial, and stuff. I was gonna go down to Fry's, but I guess they're gone.
Yep, they just closed.
Yeah, well, their shelves were empty anyway. So I'll just order this stuff, either Amazon or DigiKey or one of those, and be here in a day or two.
Okay, well, I
Um,
guess it'd be interesting to know from your judgment, do you think it's comparable or better or worse than the Caberos system? I guess that's what we're trying to figure out. And
Okay, I've been contacting the guys in the Bay Area. That's KR6DD, Andy,
Andy, yeah,
yeah, and a few others. And there's some negative feedback on the Caberos system as not being sensitive enough.
okay,
That was Steve Stearns. He says, I'm not gonna waste my time with it. And most of the guys down there still stick with the old Ramsey DDF1, which is no longer made. They liked it because it was under $200.
mhm,
And it was very, very rudimentary compared to the other stuff that's out now, namely oh boy, what do I want to ask? Call it the DF 2020T. That's I guess that's the current name for it. That seems to be a pretty good system. I don't want to brag, but it's not as good as the microfinder that I have.
okay,
The microfinder, I just pulled out my manuals for it. That's about 4 manila folders full of printed out papers. I wish I had the documentation on a computer, but I don't. Anyway, there's a lot of stuff I can program into it. I just have to figure out how again. I have to go back 20 years. You know, I think that I had run a simple hyperterm program and that would talk to it so I could say, okay, I want this output. I wanted to do this. I wanted to do that. I could program it for 3, 4, 6, or 8 antennas. Do I want a high? Do I want a low? There's highly adaptable system. The microfinder that I have will give a Grillo output. It will give a GPS NMEA output or a combination of the two, depending upon what I wanted.
well,
So
let's do a side by side when you're ready. Do you think it's a week away, 2 weeks away? John?
it's at least 2 weeks away.
Okay,
I'm in the process also of pruning my rock farm in the backyard for better harvest this coming winter.
So John, can the output of your current system, can it be modular and integrated? Can the data be exported to other to share?
I haven't worked on that part yet. Now, it does say it does have APRS capabilities. I've never really worked with APRS, so I'm not sure on the output of my DF system as to how you work APRS and what that word is going to be when it's transmitted on APRS. So when I get my system up and running, I can figure out what I have. Maybe I can at that time contact someone
okay.
that is
Well,
familiar with
let's-
doing APRS, so then we can do the next step on that.
Yeah, let's check in about 2 weeks and see where you're at with your system and
Okay.
see where we go from there.
I just
So I just have a piece of information. So I just went out to look up this. Rosie, stop it. It's Kilo November 2 Charlie
Yes.
dot US
Mhm.
Kilo November 2 Charlie.us, and then all the information on the DF 2020T is there. It looks like it's a kit. Pretty interesting.
Yep. So one of the things we hope to do is we'll compare the Caveros with the system out of New York. I have an old Ramsey system I can try to get running again, and we can do a comparison of those three as commercial products. What I've been working on is a low-end system, because I figure not everyone in the club is going to want to spend $500-600 on a DF system. So I was trying to say, why don't I try to build one that's based on a Arduino, maybe target a price of around $50, something like that. So, you know, the prototype antenna, for example, is, I'll turn off my video. Virtual background is screwing it up. None. Okay. So you should see no virtual background, but this is basically a tape measure based 440 antenna system.
Okay.
I just threw this together, but it fell apart before the meeting here. I hooked it up to my system. It shows some of the vectors, but there's some debugging I have to do. So I'm hoping in about a week or so, I'll have a homebrew system that, and I can set it up for 2 meters if we want to do that. So you guys pick the frequency we want to play with, but maybe in a week or two, I'll have a homebrew design that we can at least play with. And that way we have an entry level system for people that only want to spend $50 or less. We might enlist someone like Joshua to build us a nice 3D printed enclosure. And that would be, you know, one of the systems we can consider. Personally, I was leaning towards getting a Caveros system, but, you know, Doug, you and Brian already jumped on it, so I'm waiting for the results.
Yeah, and you know what? I'm going to tell you honestly, I don't have any favoritism except for the thing that works. And it may be a one-off, but I've had some issues with the Caveros SDR hardware, and so it's hard to say what, you know. Right now, my feeling is 60% of the time that I spent was dealing with fabrication issues.
Okay. Okay.
So that's that. I do have a question. I think you brought up an interesting point, John, which is, should we try to look for a particular frequency at this point that we would use so that we could all use the same frequency? So if we're doing side-by-side tests.
Yeah, we should pick the same frequency for the side-by-side. And for me, it's a don't care. I mean, a 440 antenna array versus a 2 meter antenna array is just different dimensions.
Right.
That's what we were kind of talking about this afternoon. You know, 2 meters, you know, means we're in the hills. If we want to work with each other, probably 2 meters would have a better, you know, a line of, we wouldn't be tied down, you know, line of sight. So maybe 2 meters would be more friendly to our terrain.
Yep,
so let me throw in another caveat. When we're doing the initial testing, we may not be that far from the Fox, and just saying, we may not be that far from the Fox. And if we're going to put these things mobile on tops of cars, the smaller the antenna is probably the better, just from a structural perspective.
Yeah, prototyping definitely is easier on 440 for sure.
Well, I built it with a tape measure because the tape measure is pretty indestructible, and I can throw it around. The only problem is my solder joints all broke apart because this is a prototype.
I heard that they've used tape measure antennas on satellites, amateur satellites.
I built a tape measure 2 meter for satellite as well as portable stuff, but neither here nor there. Let's go ahead and go with a 2 meter frequency as a starting point and see where we get next week.
Sounds good to me, Brian. Good.
So my goal is not high resolution. My goal in my design is allow as many people in the club, if they don't want to spend a whole bunch of money, can get in. But I'm hoping that between John, you, Doug, and Brian, we have a reading on which commercial product makes the most sense, because You know, I'd rather do one of those than have to support one on my own.
Question on the Foxes that people are buying, like I know Rich AA6RS and K6BAA Bruce, and I think Scott have picked up these Fox units for fox hunting. I haven't even looked them up. Those are 2 meter or 440.
You can get them both.
So maybe we could check. I'd be more than happy to reach out and see what they have, because if we're building some prototypes and we're going to actually play with some of these things that people are picking up for the fox hunt, would it be best to know what they've purchased?
Yeah, so I think for the Foxes themselves, it could be as simple as a Baofeng UV5R with a small Arduino program that keys it down every once in a while. So I think we can do that with existing HTs that we have. And for testing, I mean, even during the breakfast coffee break net, we could say, all right, let's report the vectors, you know.
Brian, you're not in Meadow Vista today.
Mhm.
Exactly. I can say, hey, from Granite Bay, I have a vector on Brian at this degree, and Doug will say, I've got an angle on this, and we can triangulate with two RDF readings.
And then 2 big black vans pull into my parking lot and coffee break goes off the air.
Hey, I can tell you, we can just hack into his cell phone. We're going to know exactly where he is. We don't need RDF.
Yeah.
Anybody else been working on any projects?
Yeah, one more item on the groups IO. I threw out there to Dennis to help us set up a sub account for RDF, a direction finding sub account, so we can keep all of our stuff under that one little section of groups IO instead of having it stuff scattered. And I haven't heard too much else other than he did point that I had 2 accounts and I got rid of one of them.
My take on that is we have fragmented Groups IO to hell, and it is impossible to find anything in there. And I know it pretty well. And so if we want to hide, I think we could have a very good chance of it. You know, so having a subgroup just means that people have to find it and join it, which means that maybe less people will join us. That would be my only concern.
Yeah, but you know, there's only a half dozen subgroups. And if you look for the direction finding under messages and stuff, it's on a long list.
6 that you see.
Oh,
I see about 17 or 18 that have basically been abandoned with 4 or 5 people in them. I'm wondering, would it be better, like in the file section, to have a subfolder for the file sharing?
That's what
okay.
That's what I've set up so far, Brian. So I was suggesting we use the files structure for now, and if we outgrow that, we can always go to a subgroup.
Yeah,
Or
because
just
as you noticed,
use
John,
a hashtag or something in the subject of the emails, like hashtag RDF.
Sure, we could try that. Because right now I'm sharing the file section of W6EK now. So there's an RDF project files
there it is. Yep.
folder.
Mhm.
So if you click on that, I've been throwing our meeting notes in here and our coordinates for Zoom meetings when we're doing it separately here. I recommend we just start here until we outgrow it, unless there's an objection to it.
I vote yes.
Any objections?
Yeah, I don't want to get hidden too fast. That's only my concern.
Yeah. It sounds like there's 2 or 3 that says let's use the file system. John, are you okay with that for now?
Yeah, which John?
There's only 2. I'm the one speaking, so it must be you.
Okay. So call it John 3 and John 4 for the number of letters in our name.
Well, John, to make it worse, my group, I've got 8 project managers, of which 4 of them are named John. So it's like, hey, John, yeah. It's like, okay, wait a minute. There's only
Well, it's
two of us
coming
here.
in.
We can work it out. All right, so that's all I've got. Anyone else?
I got one last question. I'm looking for a volunteer, just in, not for right now, but is there anybody who could do USB OTG integration of a Android device with an RPi? I could do it, but I would really appreciate the help if anybody can do that.
What do you mean integration?
Well, there's an app that goes on to the Android device and plug a USB OTG cable between the Android device and the Pi, and give it a virtual IP address, and it just starts sucking radio direction finding data out and displaying a map. So all of that's already done. It's just actually putting the OTG integration in place. It's probably simple, but I just don't know how to do it.
Okay, there is a system out there that does that. It's called SigTrax and DataTrax. The DataTrax is a dongle that fits on the back of an existing RDF system, such as the KN2C, the DF2020, or my micro finder, and it takes and changes that to Bluetooth. And from there you go to a Android or iOS system that has SigTrax installed on it. It's a $6 app, and it will then overlay onto the mapping with your bearings and stuff.
John,
So if
will you reach out to Doug and kind of make that connection then?
Okay,
That way we can see if that.
here we go. Come on, Doug.
All right.
Yeah.
Has anybody been researching any other anything else in regards to the radio direction finding and equipment and development groups?
Yeah, this is Phil. Couple of things I looked at. So I was kind of hoping to use this as an excuse to teach myself GNU radio. So I just started trying to figure out how to control some of the external hardware through GNU radio. And there's this kind of user code block. I don't know if anybody's looked at GNU Radio Companion before.
Just GNU radio a long time ago, but not recently. I've not used the companion setup.
Yeah, so the companion lets you set up blocks and then export it to Python. And there's one block that's like a user code block that I imagine could be used to control the antennas and synchronize the signals. And I'm doing this with a single RTL SDR. So I'm just kind of playing around with that. I don't know if it'll come to anything. And the other thing I came across, and I need to probably look at some videos to really get my head around what it does, but there is an application called Node-RED, N-O-D-E-R-E-D. Have you heard of that? Has anybody heard of that?
Yep.
Would that be a good way to tie together all these very different items or all these very different devices we might have on the network?
Possibly. I was hoping to use something more less optimized than Node-RED, but that's
okay.
my opinion. Mainly because I'm of the opinion that the more optimized something is, the less applicable it is.
Yeah, true.
Yeah, case in point, a transistor is broadly applicable versus a very specialized IC is only usable for that one circuit. So
right.
That's the question I have about Code-RED. Is it generic enough that it would work across an Arduino or a Raspberry Pi or a BeagleBone or whatever?
Is there any?
Well, I can look into that.
Okay.
Bill, is there any forks on Node-RED for this type of thing?
Yeah, that I don't know yet. I just heard about it on a podcast last weekend. So
A lot like GRC.
excuse me?
Looks a lot like GNU Radio Companion, and they claim Raspberry Pi and Android.
Okay. You might be onto something, Phil.
Well, we can
keep
dig a little
drilling
bit
into it.
deeper and
Yep.
okay, we'll do.
Drill into it and come back in a couple weeks with what you find.
Okay.
Personally, I was looking for some help on DSP on a Arduino, but I decided for now, Greg, we talked on the air about it. I'm going to do it using conventional analog just to get it working, and then if I have time, I'll do it on a Arduino. And I didn't know this, but I learned it after the fact. But Arduino has two architectures. One is a something like a Nano or Arduino, and
It's
the
the
other one is
mini.
called a Teensy. I don't know if you guys have heard of that one.
Yeah, I've got the mini.
Yeah.
The Teensy? Okay. So the Teensy has a lot more horsepower. And so this one might be able to host DSP, whereas the Arduino is not. So anyways, I'm going to do that as a secondary step. I'm going to do the conventional analog circuitry first, and then I'll do DSP later. So Phil, you're playing with GNU Radio and are doing digital filters on that. Let's talk.
Hey, John.
Okay.
Doug, you
John,
had,
so
Doug, you
what-
had shared with me something about the Arduino processing for bandpass.
Oh yeah, so I've tried to use. I mean, I've tried to stuff all kinds of signal processing into an Arduino, and have had very good luck with things that are sort of in the audio spectrum.
Mhm.
But as soon as I went past 50 or 60 kilohertz,
Yep.
but it just doesn't make it.
Yeah. Fortunately, the RDF is running at about 500 hertz,
Oh,
which should be within the realm of the Arduino.
well then you're probably golden.
We'll see.
Yeah. Call me if it gets painful.
You're on. Okay, that's
Well,
all I
what-
have, Brian.
Okay, what skill sets do we have represented? I know that we've kind of identified in the past what we're interested in. Is there anything that's kind of caught anybody's attention this evening for something that you might want to learn more about yourself and willing to dive into the pool and start working on anything?
I'm going to read about Node-RED just in case somebody gets really excited about that, so that I can at least speak intelligently if it turns out to be an integration point.
There we go. Cool.
The only thing I will put on the table again is, Joshua, I know you've got a lot of 3D printing capabilities. We got our eye on you. Oh,
Yeah,
you
I'm glad
too,
to help
Adam?
with 3D printing stuff.
All right,
Definitely.
Adam.
Yeah,
I've
and
been-
Adam as well.
Yeah, I've mostly been looking at Raspberry Pis and what options are available for amateur radio with Raspberry Pis and radio direction finding. Being that I'm very new to all this and learning and still studying to get my technician license, I'm still very green, but happy to jump in on the building the antennas and 3D printing things.
Yep.
But I don't know how much I can contribute with the other stuff. I would like to look into the possibility of an automatic way of our devices communicating the data back to each other to a central maybe mapping service, so that way we can all see it in real time, so we don't have to transmit our data. And I would be happy to jump in on that. I'm a software developer by trade, so
Okay.
I do a lot of Raspberry Pis already. I have 15 of them sitting here on my desk that I do various things with, so definitely want to jump in on that. Just figuring out what's available and where I can get involved the best.
Hey Joshua, how are you with Python MATLib?
I played around with a little bit. I don't do much Python. I'm more of a Golang developer these days.
Okay.
But yeah, I can look at it and probably figure out what's going on. Do you have a particular thing you're trying to solve?
Well, all the internals to Kerberos SDR are pretty much 70% of it is all MATLib,
Okay.
Matplotlib. So
I was looking at a few of the Kerberos SDRs.
yeah.
So Adam, I'm assuming for 3D printing like Joshua, all you need is a step file, right?
Yeah, or if you just have like a model of whatever needs to go in it, I can design around it.
Okay,
So yeah,
because
or even just rough dimensions, where the mounting holes are, and we can always prototype from there.
because I've been using I think Joshua is as well, Fusion 360
Yeah.
because it's cheap.
Yep.
I have SolidWorks, but it takes a long time to learn that. But Fusion 360 is cheap, but it exports a step file. If you can plot a step file, that might be interesting to do as well.
I have a lot of existing cases for Raspberry Pis of all the different sizes and Arduinos as well, because I have a few of them that I already have designed and sell in my shop. So
Okay.
we can use those as a starting point. I have a lot of them customized for various hat configurations and things for specialty devices. So have a lot of options to play around with there.
Okay. Sounds good.
Hey, John, Doug and I this afternoon were just talking about antenna spacing and, just kind of relying on you, John and others who have done radio direction finding projects before. What have you found is a optimal spacing when an antenna array is built?
It depends on frequency, right?
Right.
So on a
Yeah.
2 meter, it's in the neighborhood of, I don't know, 20 some inches. It's not a full wavelength, it's a partial. But if you want, I'd be happy to kind of propose an antenna array for car mounts.
Okay.
Yes,
It could
please.
it could be as simple as a mag mount with a whip with a piece of coax that you just space. So the coax spacing does not have to be cut to a wavelength. It just has to be long enough to accommodate the frequency range you want to search for, because it's the antenna spacing that matters in this case.
Right. And Doug, hadn't you come up with like about a third of a wave was a minimal spacing?
I was like totally guessing. That was like a rabbit out of my hat. Just looking at pictures for 440, and that and I'd love to have an equation or a relationship that says this is the frequency, this is the diameter, and it's good for a bandwidth of whatever. But I haven't found that anyplace.
It's just what you basically need is a dipole for the frequency of interest. And if you don't want to do a dipole, you can just do a isotropic whip, and that'll work as well. But a dipole is just as easy to build, especially if you're going to be mounting on a post. If you're going to be mounting on car tops, you could probably just have a half wave whip or a 3/4 wave whip. But I think that a lot of us don't want to put things on top of our roofs. So I'm basically planning on building out of a PVC across with a center post that can hold a dipole that kind of goes up and down. And that way you have at least a 2 dB gain on each of the dipoles, and it can mount on your bumper or hang out your window.
Draw me a picture.
Okay.
So like a
Really?
telescopic for adjusting the dipole length?
Yeah, with those little whips. So for 2 meter 440, you basically cut it for 440 and have a screw-on thing that you could put on and extend for 2 meters.
How critical is a resonant antenna?
I've not found it in my past direction finding ones. I didn't find the resonant frequency of the antenna to be critical. What was more critical was the even spacing of the array. So when you electrically rotated the Doppler, you got a reasonable facsimile of a circle.
Okay.
And the diameter of the circle needs to be at least a certain percentage of a wavelength.
Yes, that's right. That's right. And that's why for the 440 one, it could be this small.
So basically, be about a half wave diameter.
Yeah, yeah. But we can play around with it. These antennas are, we don't have to buy the $100 antennas. We can just grab some wire and give it a shot.
So I cheated and I went to El Cheapo eBay and bought a 5-pack of quote unquote 70 centimeter antenna, whip antennas, mag
That'll do.
mount whip antennas. And after I did a little bit of bandaging on them, they gave a reasonable SDR one for that band. And I spent $20, I think, on 5
He
antennas.
essentially shorted out the coil on the antenna when he got it. What did you say? It resonated to 800 megahertz, and they were selling it as a 440.
Yeah, exactly.
Yeah. So it's very nicely wrapped with painter's tape and then foil tape over the top of that. So it has some interesting qualities, but it's tuning.
It worked, I think.
Yeah, for tracking down GMRS noise in the roughly 440, I ended up using 4 Baofeng rubber duckies, and they work just fine.
And what were they tuned to? Oh, never mind.
Roughly 450. Roughly 450.
Yeah.
Roughly.
But it worked on a bicycle. It's like it's sticking on a PVC pipe right around with a bicycle around the neighborhood, and it worked.
So it's like grenade antennas. You get close and you're close enough.
That's right. That's right.
I read the article in the Mercury Sun about you, John.
Mercury Sun.
Isn't that the one from San Jose?
Oh, San Jose Mercury.
Yeah, man spotted on bicycle and Speedo with tinfoil hat.
That was my twin brother.
He never found the fox, but he certainly has a following.
Well, I was chasing after a fox. You should have seen her.
Should have seen all the cougars chasing John.
We're living vicariously through John.
Now, Brian's starting rumors. Thanks, Brian.
You're welcome.
We are
right,
recording,
guys.
this, right?
That's all
Well,
I got.
any interest of anyone else this evening of anything you've heard? Otherwise, I guess we're going to be making this a regular thing on the second and fourth Wednesday of the month.
Oh, I just want to throw one thing out. Even if people don't get involved in builds of the electronics, we're going to need, Brian and I were talking, there's going to be lots of need for practical testing and
Absolutely.
that kind of stuff. So we're going to have some fun gluing these things to the top of somebody's, brand new Lexus and
Yep.
driving around
Absolutely.
town.
Absolutely. We're looking for someone with a Mercedes G-Wagon that we could make into a porcupine.
Or with a Tesla Roadster.
There you go. Even
Don't know where we'd find one of those.
One thing I would be curious in working on in the future would be creating devious foxes to hunt.
Yep.
I have a few ideas on what can be done with some Raspberry Pi Zeros and solar cells and things, and that might be a fun thing in the future. Maybe after we are done making our finders.
Yeah, build the finders, and then we can build the foxes.
And I
Some will
talked to Scott, KK7AIR, and he's pretty excited about dropping something out of the airplane for us to find in the forest. So we have him on board.
Sounds like fun.
All right. Well, thanks, Brian,
Hey.
for hosting the Zoom.
Hey, before we wrap up, I was wondering if we could, I've been looking at like the schematic for some of these designs,
Mhm.
and I can't quite grasp how it works.
Okay.
I wonder, I started thinking about, well, okay, I understand the Doppler shift and how it could be synchronized to the rotating antennas, but when like if there's a signal there,
Mhm.
FM modulating happen. I don't understand how it could still work with the presence of that. So I don't know, maybe somebody could go through a block diagram of how it's supposed to
I'd
work.
be happy to do an RDF primer if you want to do that. Anyone else
Yeah.
interested?
Yeah,
All
do it.
interested, raise your hands, and I'll put you on a distribution.
Sure.
Well, you can't do it
Yes,
right now.
please.
My whiteboard's not working because the IT department gave me a new computer, and the new computer just don't get me started. Nothing works.
Well, how about
Yeah.
John, I don't want to put you on the
Any-
spot, but how about the 3-minute verbal version of how it works?
We have 4 minutes remaining, John.
Okay, in 3 minutes or less, the way it works is a clock drives the electronic switch, so the rotating antenna is basically going at about 20-30,000 RPMs, but it effectively creates a tone in the neighborhood of 400 hertz. That tone is received by an HT receiver. So out of the HT, you get audio. That's basically a
Right.
400 hertz tone. And even if there's someone's talking on it, it'd be like a subcarrier. So you can still extract using a audio filter the 400-500 hertz tone.
Oh, so you put a low pass filter to.
Right. You take a bandpass filter and you're detecting that specific tone, much like a PL tone on a carrier,
Okay.
on a repeater. So once you have the tone brought in, you compare it to the reference sine wave, which is driving the antennas. So now when you get the zero cross of the reference sign and the zero cross of the phase shifted sign, you have a phase difference between the zero crossings, and that's related to the direction. And so the direction is going to be 0 to 360 degrees, and the phase shift you're going to get is going to give you something that says 0 to 180 on the right hand side or 0 to 180 on the left hand side of north, of apparent north, or the heading you're heading. So does that make sense? So
Yeah, okay, it kind of does.
So I'm going to get a vector comparing the two sine waves, a zero crossing, that basically translates into a 0 to 360 degree thing that I can compute. Now I can
Okay.
compute it in the polar domain and say I received an angle of about 30 degrees
Mhm.
from my heading. So if I know my heading, which the GPS will tell you, I can then say heading minus 30 degrees to the right is the direction of the fox.
Okay. Yeah, it
Does
might
that
be
make
cool.
sense?
Yeah, it does. It might be cool to see like a block diagram with what
Sure.
the waveforms look like at various stages. I mean, if you have
Sure.
time to do that, I mean,
Yeah, it's not a big deal at all. I
So-
mean,
I
I'll
mean,
send out a
sometime.
Zoom. I'll send out a
Yeah.
Zoom, and whoever can make it, and we can run from there.
Yeah, that'd be cool. Thanks.
No problem. All right. Brian, are we out of time? 1 minute left. You're on mute.
45 seconds.
Yeah,
Brian,
can
we're
we-
trying to keep it an hour, and we've done that. And do we have any other things that we want to bring up before we break up this evening? All right, very good.
Video?
I am. Go
Thanks
ahead,
for
Greg.
running the net, Brian.
So the idea of having a video, where would we stick it?
I think we probably just make it a private video on YouTube and share it with people who request it.
Private or unlisted?
Unlisted.
So anybody with the link can see it, but we would limit the distribution of the link.
Yeah.
That
Okay.
sounds good.
And
All right.
of course, my laptop crashed halfway through, so I've got a missing 18 minutes in the middle here.
Well, the recording is still going here, so
Okay.
we'll get it rendered. I'll get you the link to it. All
Okay.
right, and I'm promoting this on the coffee break in the morning, and let's probably do the same, at the nets on Thursday evening. And very good. I'm kind of excited about what we're doing here, and we'll see what we can do, what we can come up with. And thank you, John. Regardless of what you say, John said, "Hey, I have an idea."
He's not talking about me, Johnny. He's talking about you.
I didn't hear that.
All right.
All right, everybody. Good evening. I'm going to stop recording now.
Okay.
Now we can start talking about everybody who's watching it.